I've recently gone back through my THREE.JS scenes and asked myself how could I make them more suitable for implementing them in a website. This brought me back to the sad blob from my very first THREE.JS tutorial. Now, while I like the animation and the scene, it doesn't really do much in the context of a website. Perhaps it serves as a banner, but then the user just scrolls down and it's gone right away. But what if we just force the user to see the 3D rendering just a bit longer? And to make it less boring and intrusive, why not add an element of interactivity to it? Shouldn't be too complicated, right? Before we get into that though, just a few preliminary remarks. I'm using my Gradient HDR pack in this scene, so if you want to follow along, check the Gradient HDR freebies on Gumroad. And if you want to support me, please consider getting the full Gradient HDR pack for just €5. If you don't have the money, no worries. You can also support me easily and for free by leaving a like on the video, subscribing to the channel and turning on the notifications. Your support really means the world to me. But now, let's get into the code. We use the original code as a starting point, so if you have any issues following what is happening here, have a quick look at the original tutorial. But as a quick recap, in the HTML we have a simple text container which contains the small headline and the social icons. Beside that we have a canvas container that contains the canvas to which we send our THREE.JS scene later on. Now we add something new though. To get some space for the user to scroll, we add a simple div with the class scroll area to the HTML and a div with the class more content to show something to the user after they scrolled all the way down the scroll area. But right now they don't really do what their names imply, so let's add some styling to our HTML elements. Importantly, we set the canvas container and the text container to position fixed in our CSS. This allows us to scroll without the elements moving at the same time. We also add a transition property to both so that we can later get a smoother fade out. Then we set the scroll area to a height of 5 viewports so that we have some space to scroll through. Lastly, we set the more content position to relative. And with that, we can already go into the JavaScript and work on the THREE.JS scene. First, a quick side fact though. If you've been following me on Instagram, you might have already seen the rendering a long while ago when I was posting daily projects. And if you haven't been following me on Instagram yet, maybe now's the right time. In the JavaScript portion of our code, we start by importing all the parts we'll need from THREE.JS. That includes THREE.JS itself, but also the RGBE loader to add the Gradient HDR later. We also add the Effect Composer, Render Pass, After Image Pass and Unreal Bloom Pass for the post-processing and the FBX loader to add our animated 3D objects to the scene. After the import statements, we basically have the same code as before. Let me just highlight the code for the Gradient HDR again. Here you can also switch between the two freebie HDRs inside of CODEPEN, which makes a huge difference since the scene doesn't use any other lights. Also, the fork XP2 plays an important role in the scene since it helps to highlight that we are moving away from the object at the center. Everything else I will skip over here, but feel free to go back to the original tutorial to get a better understanding of what is happening in the THREE.JS code. The interesting changes happen after the post-processing and the resize event listener. Here we set the variables current scroll and target scroll to 0 before we set the ease to our desired value. In this case I choose 0.00025, but you may play around with this to your liking. Then we add Theta1, Theta2 and Theta3 and set them all to 0 for the moment. We'll change them later within their respective functions. For later we will also need something like the variable animation active and animation frame request, where we set the first to true and the second to false. With that we will trigger the animation later. Then we can add our add event listener scroll to make changes according to the scroll behavior of the user. Therein we set the target scroll as the window page Y offset, meaning the actual current scroll position of the user. Then we can already call the update scroll function that we will get to soon. Now our next objective is to only have the THREE.JS scene run while the user actually sees it. Therefore we get some information first. We set the constant scroll area as the class scroll area. Then we get some information about the scroll area in relation to the viewport by setting the constant scroll area rect as the scroll area get bounding client rect. We also need the elements with the classes canvas container and text container. With that, we can start our conditional by looking at whether the bottom position of the scroll area is outside of the inner height of the window. Now, if the scroll area is outside of the viewport, we want to stop the THREE.JS scene to save resources. Thus, we set the opacity of the canvas container and text container to 0 so that they fade out. By using the opacity, we can use the transition from the CSS, which makes the fade out smoother. Of course, that only hides the element elements, so we also need to use animation active and animation frame request to stop the animation in the background. Thus we set both to false here to use the values later in THREE.JS again. This takes care of the event that the user scrolls below the scroll area. However, currently the THREE.JS scene will stay hidden even if the user scrolls back up again. Thus, in order to take care of that, we start the else by setting our animation active to true again, and we can also set the opacity back to 1. Now here's a small catch. We only want to request a new animation frame if one hasn't been requested already. That's what the if animation frame request part is for. If no animation frame is requested yet, we proceed to call request animation frame animate and set animation frame request to true. With that, we can close the event listener scroll and proceed to the update scroll function. We could also simply use the window page Y offset, but in order to get smoother transitions, we do some simple calculations within the function, which I also explained in a previous tutorial. We set the target scroll to the actual scroll position earlier. Now we set the current scroll counting up by the target scroll minus the last current scroll multiplied by the ease, which becomes the new current scroll in the next run of the function. That way we don't just skip from one scroll position to the next, but take steps in between the actual scroll positions of the user. Now we set a theta2 as the current scroll times 0.07 and theta3 as the current scroll times 0.035 to later use them to affect the camera position. In order to also call the function often enough to get enough steps in between the scroll positions, we add a set timeout which contains the update scroll function and the number of times the function is called. In this case we call the function 1000 over 60 times, which equals 60 times per second. With that, we can get back to our standard THREE.JS stuff. We start a new function update which contains our camera animation. Here we first set a theta1 as counting up by this value plus the window page Y offset times this value. We will only use this to speed up the rotation around the object later, so I don't care too much about the smoothness of theta1. Then we can update our camera position X as a negated sine function which takes theta1 plus 1 multiplied by 45 plus theta2. By negating the sine function we can change the start position. The same goes for the addition within the sine function, so it doesn't really matter besides the fact that I prefer the different start position of the animation in the case of this scene. The continuously increasing theta1 inside of the sine function determines the speed of the rotation, and by multiplying the sine by 45 we determine the distance of the camera from the center point. Now in order to move away from the center on the user scroll we add the theta2 value. Thus if the user scrolls down, the value of theta2 increases, and if the user scrolls back up, the theta2 decreases again. In order to move the camera in a circle, we simply repeat the same thing for the camera position Z, with the only difference being that we don't use a sine but a cos function. To move the camera up and down, we add the camera position Y as another cos function where we also modify the distance according to theta3 to move further up on the user scroll. Lastly, we need to add the camera look at in order to rotate around the center point. With that, we can close the update function and move on to the animate function. Therein we start the conditional that takes the animation active. Thus, only if the animation active is set to true, we use a clock to run the animation for our FBX, call the update function, update the composer, and request the animation frame. So, as we determined earlier, we only do all of that for as long as the user sees the scroll area. And that's already it. We simply close the animate function and request the animation frame again. Thank you so much for watching all the way here. I hope you found the tutorial helpful. If you have any questions or feedback, don't hesitate to write a comment. Also make sure to like the video, subscribe to my channel, and turn on the notifications for future tutorials and live streams. If you want to get some extra assets and support me even further, remember to check out the Gradient HDR pack and follow me on Instagram. I'll see you in the next one.